The Texas coastline, where land meets the Gulf of Mexico, is a place of immense energy and transformation. The waves crash against the shore, constantly reshaping the landscape, and the tides ebb and flow in a rhythmic dance that has been ongoing for millennia. This dynamic environment is not just a picturesque scene, it is a living, breathing system that supports a diverse array of life forms and human activities. From bustling coastal towns to serene natural habitats, the Gulf of Mexico is a vital artery for both nature and commerce. Recently, in early 2025, scientists conducting routine seabed surveys discovered significant cracks on the ocean floor off the Texas coast. These cracks, which appear like sudden wounds on the Earth's submerged skin, have raised numerous questions and concerns. These are substantial geological features, appearing like sudden wounds on the Earth's submerged skin. The discovery sent an immediate ripple of concern through the scientific community, as these cracks could have far-reaching implications. What do these cracks signify for the stability of the seabed, the safety of coastal communities, and the health of the marine environment? These questions are now at the forefront of scientific inquiry. What do these cracks signify for the stability of the seabed, the safety of coastal communities, and the health of the marine environment? Scientists are now working tirelessly to analyze the data and understand the potential risks. The safety of coastal communities is paramount. These areas are home to thousands of people who rely on the stability of the seabed for their livelihoods and safety. Any significant geological activity could have devastating consequences. The health of the marine environment is also a critical concern. The Gulf of Mexico is home to a rich diversity of marine life, and any disruption to the seabed could have cascading effects on the entire ecosystem. Scientists are particularly worried about how these cracks might affect marine habitats and the species that depend on them. We stand at the threshold of an important investigation to understand these mysterious fissures and ensure the safety and sustainability of this vital coastal region. The work ahead is challenging, but it is crucial for the well-being of both the natural environment and the human communities that call this area home. To grasp the significance of these cracks, we must understand the seabed's dynamic nature. The Texas coast is a geologically young environment built over millennia by sediment deposition from rivers like the Brazos and Rio Grande. These sediments, thousands of meters thick, lie atop older, compacted rocks and fault systems. This inherent dynamism means the Texas coastline is always on the move, with shorelines advancing and retreating. Understanding this constant state of flux is crucial when interpreting new phenomena like the recently discovered cracks. Is this a normal part of the coast's evolution, or does it signal something more concerning? The newly identified features are significant cracks in the seabed, stretching for considerable distances. These unsettling features were discovered using advanced marine survey technology, creating detailed maps of the ocean floor. A key question is whether these cracks are static or actively growing. Initial observations suggest some features might be dynamic, showing signs of recent change. This visual confirmation of significant disruption beneath the waves challenges our assumptions about the ocean floor's stability. The scientific community's reaction to these seabed cracks has been one of focused concern and intense curiosity. These cracks, which have appeared unexpectedly, have prompted a flurry of research activities. Scientists from various disciplines are coming together to decode the mysteries hidden beneath the ocean floor. The urgency is palpable as they work against the clock to understand the implications of these geological phenomena. Dr. Eleanor Vance, a marine geologist, emphasized the need for thorough investigation. She pointed out that these cracks could be indicative of larger, more systemic issues within the Earth's crust. Dr. Vance and her team are meticulously collecting samples and data, hoping to uncover the underlying causes. Their work is crucial in predicting potential future events that could have significant impacts on both marine and terrestrial environments. The primary goal is to gather data to understand what is happening beneath the Gulf waters. This involves deploying advanced underwater exploration equipment and research vessels to the affected areas. The data collected will be analyzed to identify patterns and anomalies that could provide clues about the origins and potential consequences of these cracks. The research is not just about understanding the present, but also about forecasting future geological activities. Concerns revolve around seabed stability. If these cracks are a sign of weakening structures, it could lead to significant geological shifts. The stability of the seabed is crucial for maintaining the balance of marine ecosystems. Any disruption could have cascading effects impacting everything from underwater habitats to coastal regions. and potential subsidence, which could alter coastal water depths and increase flood risk. Subsidence, or the gradual sinking of land, can exacerbate coastal erosion and lead to more frequent and severe flooding. This is particularly concerning for areas like the Texas coast, where communities are already vulnerable to rising sea levels and extreme weather events. Understanding the link between seabed cracks and subsidence is vital for developing effective mitigation strategies. Dr. Ben Carter highlighted the unknown variables. He stressed that while some data points are clear, many aspects of these cracks remain shrouded in mystery. The scientific community is working tirelessly to fill these gaps in knowledge. Dr. Carter's team is focusing on the potential chemical and physical changes occurring in the seabed, which could provide further insights into the causes and effects of these cracks, and the potential impact on marine habitats. The Gulf of Mexico is home to diverse marine life, and any disruption to the seabed could have far-reaching consequences. Coral reefs in particular are sensitive to changes in their environment. The health of these reefs is a key indicator of the overall health of marine ecosystems. Protecting these habitats is a priority for researchers. The interconnectedness of Earth's systems means that understanding these cracks is crucial for predicting future occurrences. The Earth's crust, oceans, and atmosphere are all linked in complex ways. A change in one component can trigger a series of reactions in others. By studying these cracks, scientists hope to gain a better understanding of these interactions and improve their ability to predict and respond to geological events. Researchers are piecing together what these features signify for the Texas coast. They are using a combination of field observations, laboratory analyses, and computer models to build a comprehensive picture. This multidisciplinary approach is essential for capturing the full scope of the issue. The findings will inform not only local but also global strategies for managing coastal and marine environments. This is a complex puzzle with many pieces still missing. Each new discovery adds a piece to the puzzle, bringing scientists one step closer to understanding the full picture. The work is challenging, but the potential rewards are immense. By solving this puzzle, scientists hope to protect marine ecosystems, safeguard coastal communities, and enhance our overall understanding of Earth's dynamic systems. Determining the cause of these seabed cracks is a pressing question. These cracks, which can be seen stretching across the seabed, raise concerns about the stability of the region and the potential risks they pose to both marine and human life. Understanding their origin is not just a matter of scientific curiosity, but a necessity for ensuring safety and sustainability. Natural forces like tectonic adjustments and sediment compaction are prime candidates. The Earth's crust is in a constant state of flux, with tectonic plates shifting and grinding against each other. This movement can create significant stress on the seabed, leading to the formation of cracks. Additionally, the weight of accumulating sediment layers can cause the ground to compact and fracture over time. Human activities such as groundwater withdrawal and oil extraction can also induce subsidence and cracking. When large volumes of water or oil are extracted from underground reservoirs, the land above can sink, creating fissures. This subsidence can be exacerbated by the removal of natural support structures, leading to more pronounced and widespread cracking. Pinpointing the exact cause is a complex scientific detective story, often involving an interplay of natural processes and human pressures. Scientists must sift through vast amounts of data, looking for clues that can help them understand the underlying mechanisms. This involves not only fieldwork but also sophisticated modeling and analysis techniques. Scientists will gather diverse data sets, including seismic surveys and sediment core samples, to build models testing different hypotheses. Seismic surveys can reveal the structure of the seabed and the presence of faults, while sediment core samples provide a historical record of geological activity. By combining these datasets, researchers can develop a more comprehensive understanding of the factors at play. The process involves careful elimination and correlation, looking for spatial relationships and timing. By mapping geological data and examining spatial patterns, scientists can identify areas where cracks are most likely to occur. Correlation analysis helps them determine whether these patterns are due to natural processes, human activities, or a combination of both. Collaboration between geologists, engineers, oceanographers, and data scientists is essential. Each discipline brings a unique perspective and set of skills to the table, allowing for a more holistic approach to the problem. By working together, these experts can develop more accurate models and more effective solutions. Understanding the cause is critical for predicting future occurrences and developing mitigation strategies. By identifying the factors that contribute to seabed cracking, Scientists can create predictive models that help anticipate where and when cracks might form. This knowledge is crucial for planning and implementing measures to protect both the environment and human infrastructure from potential damage. The appearance of seabed cracks raises concerns about potential environmental consequences. Physical disturbances to the seafloor can alter water flow patterns and sediment transport, affecting benthic communities. Saltwater intrusion could contaminate freshwater supplies and alter estuarine environments. The Texas coast's marshes, seagrass beds and estuaries are critical habitats that could be degraded or lost. Scientists are monitoring for early signs of ecological stress in the surrounding areas. Understanding these potential environmental ripple effects is crucial for protecting the Texas coast's natural heritage. The Texas coast is an economic engine, home to busy ports, the energy industry, and fishing and tourism. The discovery of seabed cracks carries potential economic tremors. The stability of the seabed is fundamental for infrastructure like pipelines, communication cables, and offshore platforms. If the seabed becomes unstable, the risks of damage and operational disruption are immense. Local economies dependent on the coastal environment could also face significant impacts. The potential long-term costs include monitoring, geotechnical investigations, and engineering works. Investing in understanding and addressing this issue is a sound economic imperative. Proactive measures are necessary to mitigate risks and protect the Texas Gulf Coast's economic powerhouse. The scientific community is intensifying research efforts to understand the mechanisms behind the Texas coast cracks. Leading theories include natural geological processes and human activities. Research employs advanced technologies like high-resolution sonar mapping and sub-bottom profilers. Sediment core samples provide invaluable information about the sediment properties and history. Monitoring networks track ongoing ground movement with precision. Long-term solutions and coastal defense strategies will be based on the best available science. The discovery of seabed cracks is a reminder of our planet's dynamic nature. The key is to approach this challenge with scientific rigor and long-term vigilance. Continued research and international collaboration are vital. Public awareness and transparent communication are crucial for effective navigation. Government agencies must coordinate efforts and support research. This situation underscores our responsibility as stewards of the planet. The cracks beneath the Texas coast urge us to listen, learn, and act wisely to protect these vital regions. As we turn our gaze towards the future, the Texas coastline stands at a crossroads. Predictions based on current data suggest that the seabed cracks could evolve, potentially altering marine ecosystems and coastal landscapes. Scientists are working tirelessly to model these changes, providing crucial insights into what might lie ahead. Preparations are already underway. Coastal defense initiatives such as reinforcing seawalls and restoring natural barriers like mangroves and wetlands are being prioritized. These efforts aim to mitigate potential impacts on communities and local economies. Public participation is also essential. From local conservation groups to individual citizens, everyone has a role to play in safeguarding the Texas coastline. Simple actions such as reducing carbon footprints and supporting sustainable practices can collectively make a significant difference. The future of the Texas coastline depends on our collective ability to predict, prepare, and protect. With continued vigilance, scientific advancement, and communal effort, we can strive to ensure that this precious region remains resilient and vibrant for generations to come.